Welcome. In this explainer, we're breaking down the playbook for turning your good student work into a truly professional grade engineering submission. We're going to cover how you can move from just getting a project done to delivering it with real excellence.
So let's kick things off with the big question. How do you bridge that gap? It's not just about getting the right answer. It's about the precision of your build, the clarity of your evidence, and, of course, the professionalism of your presentation. We're going to walk through this in 5 key stages. First, we'll look at the playbook itself, then get into the hands-on build. After that, we'll cover how to best document your work, how to explain it all in a report, and finally, we'll wrap up with those professional touches that make a huge difference.
Okay, first up, let's talk about the playbook. You should think of the program's guides as more than just suggestions. They are the official rulebook for success.
These guides are essentially your complete blueprint. Seriously, they cover everything you're going to need, from the basics of putting circuits together and taking clear photos, all the way to writing final reports and citing sources the right way. Mastering these is definitely step 1. Next, let's dive right into the build itself. This is where all that theoretical knowledge gets real and becomes something tangible. At the heart of your prototyping is the breadboard. It's just a fantastic tool that lets you build, test, and tweak circuits on the fly, all without the hassle and permanence of soldering. It's basically your sandbox for innovation. Now, for your connections, you've got 2 main choices. Hookup wires are amazing when you need a very specific length for a cleaner, more permanent project, but jumper wires, with their handy pre-attached pins, are the absolute go-to for speed and flexibility when you're prototyping. Knowing which one to use and when is a real pro move. And remember, a clean breadboard isn't just for show. Organized, maybe even color-coded wiring can save you from those maddening errors like reversing your power rails or dealing with loose connections. A neat board is a functional board, and trust me, it's 1,000 times easier to troubleshoot. Okay, so you've built an amazing circuit, but if you can't document it clearly, all that hard work might just get lost in translation. Capturing the evidence is every bit as important as the build itself. So when you go to take a photo of your work, just run through this little checklist. A straight, top-down view with a sharp focus, good lighting, and a background that isn't distracting. That all ensures that whoever is looking at your work sees exactly what you want them to see. Now, just look at the difference here. The bad example has all this glare, and the angled view totally hides some of the connections. The good example? It's perfectly clear, totally unambiguous. It's amazing how a few simple changes in how you shoot can make a world of difference in how your work is perceived. The same principle applies to data, too. A scatter plot is such a powerful tool for visualizing relationships. The process itself is pretty straightforward. You enter your data, create the chart, and then, and this is critical, you label your axes and add a trend line. That's how you turn a boring wall of numbers into a clear, compelling story. All right, so you've built it and you've documented it. Now comes the art of explaining it. A technical report is your chance to really communicate the why and the so what behind your project. This structure right here is basically the universal language of science and engineering. It guides your reader on a logical journey. What you set out to do, how you did it, what you found, what it all means, and finally, what the main takeaway is. Following this format is key to making sure your work is understood. Now, you really need to pay close attention to this distinction. Your results section is for pure objective facts, like the measured voltage was 5.1 volts. Your discussion section is where you give context and analysis, like the voltage of 5.1 volts suggests the circuit is operating as expected because you never, ever want to mix those two. And always remember this, writing a clear report isn't just some academic hoop you have to jump through. Out in the professional world, this is an absolutely core skill. Your ability to communicate complex ideas clearly is what will really set you apart. That same sense of professionalism applies to your code. Don't just email over a random collection of loose files. The standard professional procedure is to organize everything neatly into one folder, compress it into a single .zip file, and then submit that one clean, self-contained package. Before you even think about hitting submit, please run through this quick quality check. Is your header comment filled out? Does the code actually run? Are the files named something logical? And consistent formatting, like indentation, isn't just about making it look pretty. It makes the code readable and maintainable both for you and for anyone else who looks at it. We are now at the final stage, the professional finish. These are the little details that take your work from just being good to being great, and they show a real commitment to quality.
In this program, the standard for citations is IEEE. It's a really clean, logical system. You just put a number in brackets in your text, and that number corresponds to a full reference in a numbered list at the very end. It keeps the main body of your report looking so tidy and readable. And this slide illustrates perfectly how it works. That simple little 13 in your text acts like a direct link, pointing your readers straight to all the detailed source information in your reference list. It's just elegant and efficient. And here is one final, really powerful tip for all of your technical writing. Banish vague words from your vocabulary. Don't say a result was big or a process was fast. Give me the numbers. Say the signal increased by 35 decibels, or that the process completed in 110 milliseconds. Precision is the language of engineering. So, when you look at the whole anatomy of a great project, you can see it's really a balance of all these parts. The build, the evidence, the explanation, and that final polish. They all have to work together to create a submission that truly demonstrates excellence. So I'll leave you with this final thought to chew on. Are these guidelines just about getting a good grade in a class? Or are they about building the fundamental habits, precision, clarity, professionalism that are going to define your entire career as an engineer? Something to think about.